Okay, today we are going to start the next chapter. Okay, I have not graded your tests yet. I apologize, I did not get those done yesterday. What's that? Why would you wait?
Because he doesn't want to do work.
So this next chapter is about transformations. Okay, we have a few different types of transformations that we're going to look at. Today we're going to start with reflections. Okay, so we're going to do reflections, translations, and rotations in this chapter. Today is reflections. We're actually going to do reflections today and tomorrow. So we're just going to start with reflecting a basic image across a line. Now, on the front of this page, we're not going to do any measurements. It's not going to be exact. We're going to kind of eyeball what we're going to do, but we're going to get the process down so that it becomes much easier when we throw in a coordinate plane. So, first of all, a couple of vocab ideas up here in the top. So, the line that we are reflecting over is called the line of reflection. Hopefully that makes sense. Don't need to explain that. The original image, or the original figure before we reflect is called the pre-image, and then after we reflect, it's called the image. Now, the key is that each point that we are reflecting, and we're going to go point by point. We're not going to try to reflect the whole figure at one time. We're going to take one point at a time. The key is that a point is the exact same distance from the line of reflection as its reflected point. So the way that we're going to do this, we're going to take one point, and I'm going to draw a line that's perpendicular to my line of reflection. So if I take point A here, and I sketch a line perpendicular to the line of reflection, that's going to be the eyeball part here at first, okay? We're going to try to make them as perpendicular as possible, but we're not going to use any tools or anything to do that. So,
There's testing listed after the test. That's what Terry said.
It's a practice SAT. It's not. So we're gonna kind of eyeball / measure the distance on a perpendicular line from a point to the line of reflection. And then we're going to go that same distance to get to my reflected point. Okay? Now, as far as notation, whenever we reflect or translate or rotate a point, if my original point was A, my new point is going to be A prime. Okay? We just put a little apostrophe up there. Okay, now, when we get into multiple transformations in one problem.
Wait, did they say we're at the community room?
I think they put the community room or the boardroom, but I checked with Terry again.
So helpful.
Okay, I know you do so much.
When we get into multiple transformations in one problem, okay, the first operation that we do would be A prime. The second operation that we do, we would just put a second little apostrophe up there to denote that's the second transformation that we did on that point. Okay? What's that? Yeah, it would be double prime. Right? We do it 3 times, triple prime. Right? And I mean, we will look at problems where we do 2 or 3 transformations at once. So down here, okay, we're just going to practice a few of these. And like I said, we're not going to measure and do this exactly. We're just going to kind of eyeball, okay, and try to draw perpendicular lines as close as possible. Okay, but if I want to do number 1, okay, well, I'm going to start point J, kind of try to draw a line perpendicular to my line of reflection, and then try to go about that same distance on the other side to get to J prime. Okay? I'll do the same thing with K. Well, what happens if the point is on the line of reflection?
It goes to the other side.
But it's on the line. So how does it?
Kind of like makes a different angle. It looks different.
If it's on the line of reflection, its reflection is going to be in the same spot. Right? So K and K prime will actually be in the exact same spot here. Okay? If I'm already on the line of reflection and I reflect, it's not going to move. That's like if you put your face right up against the mirror, right? Your reflection's touching itself. Right? It's not. You can't see a distance between the reflection. Then if we do the same thing for H, let's see here. Try to go that same distance on the other side. That's about right. So H prime will be right there. And I can draw my reflected triangle. Lesson. Okay, so you should be able to visualize then. If I were to take the paper and fold it across line M, my figures would line up. Okay, that's the idea of a reflection. I know you guys have worked with reflections in some capacity before. Okay, it's just folding over that line. Any questions so far?
So the lines are curved.
No. The lines will never be curved. A curved line isn't a line.
It's some curved thing. What would that be called?
No, ray is still straight.
Curved. Shape.
A function, I don't know. I mean, could be like a parabola or something like that. Or a circle.
Yeah, like it's not. It's like it's not straight. Like a bench or something. I don't know.
No, we're not going to do anything like that. All right, so let's take a few minutes and you guys practice a few of these. Okay, we probably don't need to do them all. Okay, but just practice a few of these. Did we get some things that looked like this?
Number 6.
Number 6 tripped you up? So I think as I was walking around, I think 4 and 6 tripped some people up. Okay, I think some people were struggling with drawing perpendicular lines to the line of reflection. Okay, so if we look at number 6, okay, my original figure was down here, and I want to draw perpendicular lines. I'm not extending this side out or drawing a line anywhere. I have to make sure the line I'm drawing is perpendicular to the line of reflection, meaning it meets it at a right angle, right? So if I start at X, and I want to draw a perpendicular line, let's see, that would kind of end up like that. Okay, and then if I come across that line that same distance, I'll end up at X prime there. Okay, same idea for all of these. Okay, to draw, we may need to extend this line out a little bit. Okay, to draw a perpendicular line. Okay, from point Z, it's got to come up there. So then if I go that same distance on the other side along that line, I'll get to Z prime. Okay, we have to make sure those lines that we're drawing are perpendicular. Okay. So any other questions about these here? So then on the back, we just introduce a coordinate plane into this idea. It does. It makes it a lot easier if we introduce a coordinate plane. Okay, so There are a few rules up here, but I actually think it's a lot easier to just use the graph rather than memorize these rules. Okay, so I mean, if you want to use these rules, okay, if we're reflecting across the x-axis, we would just take the opposite of the y-coordinate. So, for example, if I have the points 1, 2, and I want to reflect that point across the x-axis, if I take the opposite of the y-coordinate, leave the x-coordinate alone, that would just go to 1, -2. Let's reflect across the y-axis. If I take that same point, and now to reflect across the y-axis, I just multiply the x by -1. Or, yeah, by -1. So take the opposite of the x-coordinate. And we're not going to do any of these yet. We'll do this last bullet tomorrow, where we're reflecting across the line y = x. Okay, but when we do that tomorrow, all we're going to end up doing is switching x and y. So if I start with the point 1, 2, and I reflect across the line y = x, that would go to 2, 1. Okay, but I actually don't even like using these rules. Okay, I think it makes a lot more sense if we just do it on the graph. What I mean by that, okay, is if we look at this example that's done for us up here. Okay, they say take this quadrilateral and reflect it across the x-axis. Okay, well, I'm just going to go point by point and count the distance to the x-axis. Right? So if we start at point D, well, that's 1, 2, 3 away from the x-axis. I'm going to go that same distance on the other side, 1, 2, 3, to get to D prime. Same thing for the rest of my points. I go to E. It's 1, 2, 3, 4 away from the x-axis, so I go 1, 2, 3, 4 to get to E prime. G is 1 away from the x-axis, so G prime, let's go another 1. F is 1, 2, so F prime is another 1, 2. Okay, so that's all we're doing. We're just counting the distance from each of our points to the line of reflection, and then going that same distance on the other side, just like we did on the front. But if we have a coordinate plane, I think that makes it a little bit easier. Okay. Now, if instead of reflecting across an axis, well, actually, before we do these, let's jump down to numbers 5 and 6. These ones are reflecting across an axis. So for both of these, I'm just taking these coordinate points and then reflecting them across the x-axis in number 5, the y-axis in number 6. Okay, so if I plot my original figure, -2, -1 is D, E is at -1, 3, and F is at 3, -1. So I want to take this figure and reflect it across the x-axis. Since the x-axis goes right through this triangle, my new triangle is going to be kind of on top of itself. Okay, but what we're doing is just counting that distance. So from D to the x-axis is 1, so D prime just be 1 up. F to the x-axis is 1, so F prime will be right here. And then E to the x-axis is 1, 2, 3, so E prime will be 1, 2, 3. We get a nice picture of where that reflection is. And hopefully we can see, on the graph, if I were to fold right across the x-axis, it would be on top of each other. Questions? Okay, why don't you guys try number 6 then? Okay, go ahead and plot A, B, C, and D, and then reflect those in the y-axis. Did we get something that looks like this? Okay, so this one we reflected across the y-axis. Right, so we just counted the distance from each point to the y-axis, and then went that same distance on the other side. Okay. Any questions on reflecting something in either axis? All right, so then if we jump back up to our other exercises here, we're reflecting across lines other than the x or y axis. So we have to understand where these lines are. It says take this triangle FGH and reflect it across the line x equals -1. Where's the line x equals -1?
So it's gonna go this way, and it's gonna be right beside on the -1.
Yeah, so x equals some number is a vertical line, right? So, I mean, it might be a good idea to make a note of that. Right? X equals some number is a vertical line. So x equals -1 just means I want the line where all of the x coordinates are -1. So that's going to be this line right here. Right? X equals -1. So now, if I want to reflect my figure across that line, I'm just doing the same thing, counting the distance from each point. Well, F is 1, 2, so I'm going to go 1, 2 to get to F prime. G is on the line, so G prime will be in that same spot. And then H is 1 away, so H prime will be right here. So my figure reflected across the line x equals -1 will be right there. Okay, so now it says do the same thing, reflect this figure, but now across the line y equals 1. Where's that line? it's going to be on the y.
Be on the line.
So yeah, it'll intersect the y-axis at 1, right? So this would be the line y equals 1 here. Okay, where all the y coordinates are 1. So now I'm taking this figure, my original triangle, and reflecting across this line. So I'm just going to do the same thing. I'm going to count from F to this line is 1, 2, 3, 4. So go 1, 2, 3, 4. Then H is 1, 2, 3. So 1, 2, 3. There's my H. And G, 1, 2, 3. So 1, 2, 3. There's my G prime. So this, the red one, would be that triangle reflected across the line y equals 1. Okay, so for these, I mean, the only difference is we have to graph these vertical and horizontal lines. Okay, x equals is always a vertical line, y equals is always a horizontal line. Okay. Questions? All right, then you guys go ahead, try the next one. With two of these on one graph, it is kind of hard to see what's going on. Right? But if we, let's see. I think the first one was in x equals 0, so they labeled that as all the single primes. So I think the red one here would have been the reflection across x equals 0. Right? X equals 0 is just the y-axis. Right? And then all of the double primes here would be our reflection across y equals 1. So that's green one here. Okay, I know it's kind of hard to see with a couple of these on one graph. Okay, but did we? It's a magic trick. Did we come up with something like this? Okay. Any questions on any of these ideas here?